Hi, we are team number seven, made up of Camilo Infante, Eric Leal, and myself, Cesar Valdez. And in this project, we are going to look at the melting pole status in 2025, because in this year, satellite data and climate models reveal that Arctic sea ice has reached its lowest winter maximum in the 47-year satellite record, while Antarctic ice continues to show signs of instability. So, with this project, we need to answer the question of if we are in trouble. So we as a team analyzed the global temperature record in the global temperature.csv database to measure how unusual present conditions are relative to a 30-year climate baseline. Using the 1951 to 1980 reference period, we convert temperatures to anomalies and smooth them to reveal persistent change. This provides an engineering-oriented view of warming relevant to polar ice stability. The theoretical background, we have four different components. The temperature anomaly is each month's temperature minus the 30-year baseline mean, the data from 1951 to 1980, to make decades comparable. Why anomalies? This removes absolute scale and seasonal effects, which highlights long-term change. Smoothing is we did 12-month rolling mean and 120-month rolling mean to reduce weather noise. And trend estimate is a simple linear regression on annual smoothed anomalies. The objectives of this project are to quantify current global warming versus baseline period, estimate warming rate, the degrees Celsius per decade, and highlight recent extremes, and communicate implications for industrial decision making with clear visuals.
So now going to the methodology part, we found out that the analysis began by cleaning and organizing the global temperatures dataset, parsing monthly dates, and adding the year and month columns. And for the sample, the dataset includes monthly global land and ocean temperature averages from 1850 to 2015, totaling 992 valid months. And finally, each entry represents a single calendar month and reflects global, not polar, specific conditions. A consistent upward trend in temperature anomalies is evident, and linear analysis helps quantify warming relevant to polar ice stability.
Here we plot monthly global temperature anomalies relative to 1951 to 1980 baseline, plus a 12-month rolling mean to cut weather noise. In our file, the baseline mean is equal to 15.3 Celsius degrees. Over the most recent decade covered, the mean is equal to 15.836 Celsius degrees, which is 0.536 Celsius above the baseline. The smooth line meanders near zero in the 1800s, rises modestly early the 1900s, then turns consistently upward after the late 1980s. A simple linear fit to the annual smooth anomalies yields 0.053 Celsius per decade. The key takeaway is structural. Positive anomalies have dominated recent decades, and the smooth curve keeps rising. Evidence of a persistent shift, not a short blip. We also checked that using reasonable alternate 30-year baselines move to zero line but doesn't remove the upward trend. On the second panel, we use a decadal smoother, which exposes the underlying climate signal. The curve sits near or under zero through much of the 19th century, edges up in the early 20th century, and then accelerates after 1975, ending well above zero point 0.5 Celsius by 2015. The small table confirms that the warmest years cluster at the end of the record, which is exactly what we expected when the whole distribution shifts warmer. For industrial engineering, this implies higher risk to Arctic routing, permafrost fund assets, and coastal facilities, plus knock-ons on the insurance and inventory policy. The limitation is that this is global mean series that ends in 2015. Integrating current sea ice extent volume will refine magnitudes, but the direction of the risk remains the same. In conclusion, we are in trouble. Current conditions are well above the baseline and rising at 0.053 Celsius per decade. The anomalies and positive Celsius per decade trend indicate a sustained shift to a warmer climate, consistent with faster polarized loss via ice albedo feedback and warmer ocean and air. And we want to acknowledge the support of DeepChicks community blog, which provided us a very useful dataset to achieve our challenge. Thank you.
Thank you.